Hello, everyone. My name is Farzad Jalaei from National Research Council Canada. I presented this paper back in Corfu on July 14, and unfortunately, due to the technical issue, I was asked to do the presentation again and record it for putting it on the YouTube channel of the EC3. So this paper is mainly about automated quantity takeoff and lifecycle costing in construction projects using the OpenBIM approach. Before getting into the full scale of what we have done in the paper, I'm giving you a brief introduction about like what NRC is doing in Canada. National Research Council and specifically Construction Research Center is the R&D arm of the federal government who are doing more activities on, advising the regulatory framework in terms of adopting the new technologies and what emerging technologies and modern methods that we can offer to the construction sector, and specifically how we can reflect it into the codes, regulations, and like a national policy. To do this, since 2022, we started a platform at the national scale with around like $192 million investment from the federal government of Canada to decarbonize the construction sector at scale. And under this big initiative, we had the R&D program that's called Construction Sector Digitalization and Productivity, which we are doing the R&D activities in terms of, as I mentioned, advising the regulatory framework on adopting the new technologies and specifically what we can do on digitalization of construction processes and modern methods of construction. As you can see in this report, that one of those very first reports that we have published, like the main R&D streams of the digitalization of construction sector and the productivity policy are kind of like captured, and you can see that the main areas that we are focusing on, from circular economy, life cycle, environmental and cost assessment, digitalization of codes, permitting, and all kind of like a data management during the life cycle, and how to translate the digital signals into the physical actions by adopting the modern methods of construction, and cyber physical systems are part of the main areas to do the R&D. Beside that, we have also like published the digital construction platform at National Research Council scale. It includes the digitalization of national construction codes and development of the National Common Data Framework. I witnessed some of those activities and presentations in the EC3 conference related to doing the survey in different areas, different countries, and we saw some similar activities are going on in European countries in terms of developing the digital construction platform. We are doing the same at NRC level, and we are trying to start from ourselves how we can make our national model codes and national master specification some sort of machine readable, BIM compliant, and how we can translate all those semantics, syntaxes, concepts. You can see here processes, workflows, and all those practices in terms of adopting the open BIM standards in there. So for that reason, we collaborated with the Building Smart International and its Canadian summit. Plus, we had university partners in helping us to shape our like a digital construction platform, including the common data environment, and how this common data environment is going to interact from federal level to the province level and to the project level. So this is kind of like a background on what NRC is doing, how we are adopting and acknowledging the OpenBIM standards. And from here, we kind of like translated into this life cycle data management in capturing and quantifying life cycle environmental and cost assessment. NRC had a long history in doing the LCA analysis. And to do that in this program and through the digitalization of construction processes, we decided to kind of see how we can standardize the pathway from IFC, OpenBIM standards, IFC submission in terms of how to validate the IFC submissions by developing the information delivery specification IDSs for embodied and operational carbon. So we are normally like receiving the IFC. We have the IDSs for embodied and operational carbon. We are assessing the IFC submissions against those IDSs to make sure that it has the minimum data requirement. And the next step is how to connect and map the bill of works, bill of materials coming from the IFC files to the carbon dataset, life cycle inventory dataset. For now, we are using the EcoInvent as we have a good representation of Canadian data in there, and it goes all the way from production to the end of life. It's not kind of like a accomplished yet. We are like working on different pieces together like with the research team at the Construction Research Center, but it is kind of like in a good shape right now in terms of capturing those production stage, construction stage. You can see here we are using the open routing system as a GIS tool in terms of capturing the distances between the manufacturer's, vendor's location and the construction site, calculating the distances and multiplying it to the means of transportation to capture the transportation related carbon activities. This goes all the way from production, as I mentioned, to the end of life. And as you can see, we are using all open source engines behind the scene in terms of reporting the results, and specifically the results related to the climate change that we are mainly looking for, and also reporting the contribution tree. What stage of the life cycle, what product, what assembly has the highest impact and contribution in the whole scale of the life cycle of environmental carbon quantification and assessment process. In this paper, the same analogy, same approach goes to the cost estimation. So you can see that we are having the specifically cost data that is called RSMEs, and this is in North American scale, but we have the Canadian version of it, like for the Canadian major cities. And we are taking the same analogy in terms of using IFC, kind of linking the RSMEs cost data set into the IFC material definition and taking it all the way to the element level and including the material, labor, and equipment cost computed per element. And also on the other side, we have this capacity to use the IFC data in terms of providing the minimum information and data requirement to conduct the life cycle costing functionality by the RSMEs. So the four-step methodology includes the developing the IFC model, building the cost-enriched IFC material, equipping the elements with those materials. So it means kind of like replacing or assigning cost-enriched IFC materials into for this paper specifically, we used three main elements: walls, floors, and ceiling, and we kind of like put those data inside the IFC, and it all implemented with IFC OpenShell to read and write the IFC, attach a prototype property sets, and compute the quantities. This is kind of like a core technical slide that shows how the prototype goes, through the IFC objects and uses the materials as the bridge between geometry and the cost data. And as I mentioned, it all happened in the IFC OpenShell as the implementation mechanism for reading, writing, property sets, and also quantity access. And for each cost element, we had to some sort of like normalize it to the cost data. So we deal with different type of units in the RSMeans. So we need to select required IFC quantity, applying the unit conversion coefficient to match with that RSMeans unit, and multiply it by unit rates for all those kind of like materials, equipment, labor, operation, and overhead and profits, and kind of storing the element level cost outputs inside the IFC properties. So these kind of like formulas are applied behind the scene in terms of developing those kind of like cost values. And as I mentioned, RSMeans has one feature in terms of using the historical data in terms of running the life cycle cost analysis and developing and providing the preventive cost and maintenance and replacement costs for next 10 years. And to do that, it requires some sort of inputs, kind of like a gross floor area, number of floors, floor height, building perimeter. So for all these kind of like data needs to be manually entered into the RSMeans cost data in terms of running this LCC analysis. But our prototype is able to, removes this manual effort and error in collecting the inputs. So we are providing all those inputs. The inputs comes from the IFC file of the whole asset. And providing it to the user in terms of running this LCC analysis for to kind of like have this projected data related to the preventive cost and maintenance and replacement costs through this LCC analysis. So it has also some sort of a remaining extension area in terms of including the operational and end of life costing as the future step of running the LCC analysis. We have applied this pathway and the whole idea and the methodology in one use case in the city of Toronto for the office building. This low-rise office building, and the results are kind of like reported for three main elements, as I mentioned: wall, floor, and ceiling, and kind of like showing the contribution of each element in terms of cost data from material to all the way to equipment, labor, and some sort of including overhead and profits. And the ultimate goal for us is to sort of get to the level of representing Canadians or Canada's digital twin platform. We have started this pathway collaborating with universities, specifically Carleton University. Sims Lab is helping us in deploying and running the proof of concepts on some of the use cases with this platform. This is called the Canada's Digital Twin. It is evolving, and all those items related to the environmental impact assessment and cost assessment are going to be added to this platform as the added plugins. But it is kind of a federated environment in terms of having all those sort of data, as you can see, the maps, BIM data, point cloud data, sites data, buildings data, like a file storage, and the way of visualizing it all in one federated browser-based environment is going to be represented. At this point, we have this sort of like some use cases that is entered into this Canada's Digital Twin platform. We are using all non-proprietary solution, specifically the one OpenBIM standards that is provided to us and is available by Building Smart International. And on the other side, we are using open libraries of the city, some federal libraries included in there. And we are expanding it in terms of turning these offline models into online, dynamic, real-time, models in terms of controlling and operating the digital representation of the physical assets. That's the ultimate goal. We are working on that, and we are trying to kind of expand different pieces of this puzzle in terms of making these different sort of data coexist beside each other, having this visualization, like a capability, and connecting all these data into any sort of cost and carbon, energy, like a geospatial, all those kind of like other analytical tools in terms of providing this full platform to our clients and to the public, to the industry, in terms of being able to facilitate and do the asset management and make very optimum decisions in terms of operation, maintenance, replacement, end of life. So this is kind of like a full life cycle scale approach that we want to apply. And the one final item is that Government of Canada is acknowledging this pathway, and the government organizations are collaborating with us, and we are trying to kind of like use this sort of unified and browser-based federated environment to manage the assets at the federal level. That's pretty much it. I hope you enjoyed this presentation. Actually, when I presented it in Corfu, it got a very good attention, and we had so many interesting questions and discussions after the presentation. So I hope you liked this presentation, and please reach me out if you have any questions or further points to discuss more. Thank you so much, and have a